So, hello everyone. My name is Sergio Sastre. I've been doing Android development for over 10 years, and I'm a super big fan of TDD, test-driven development. And after using Compose and Previews for a while, there was a moment in which it clicked on my head. It was like, oh, why not to use Composable Previews and TDD to TDD-fy the UI? And I didn't only realize that it was possible, but also that it had more benefits than I expected. And that's how I came up with this development workflow. So, before showing you how CPDD works, Composable Preview Driven Development, I need to explain two fundamental concepts it is based on. So the first one is screenshot testing on the JVM, and the second one is TDD, test-driven development. So I would like to know, before I continue, how many of you have heard of screenshot testing before? Raise your hands, please. Okay, quite a few. How many of you are using it? Okay. And what about TDD? How many of you have heard of TDD? Okay. And how many of you are actually doing TDD? Okay, more than I expected, not bad. Good. I hope that after this tech talk, more people will do TDD and also screenshot testing. So yeah, let's start. Yeah, how screenshot testing actually works. But I will explain it in the context of Composable Preview Driven Development. So for screenshot testing, you need a special library for it. I'll mention some options later. But something that all these screenshot testing libraries have in common is that they provide two tasks, usually via Gradle plugin. The record task, that is just to generate a screenshot file out of a UI component. So in this context, a composable. And this screenshot file reflects what the design should look like. Then we have the verify task that also generates a screenshot file, and then it compares this file that is just generated to one that we have previously recorded. So let's see how these tasks are used. So first of all, write UI code for a new feature, and in this case, a composable. And it's also very common while you are writing code for a composable that you add a preview. So you also can check what it looks like without starting the device, starting an emulator or whatever. Yeah, in the context of CPDD, actually, this is equivalent to have or to write a screenshot test. Because the screenshot tests are going to be generated out of the previews automatically. You won't have to do anything. I'll show you later how. And once the UI looks as in the design, you just execute the record task. And this one will generate a screenshot file out of the composable inside the preview. So later on, we decide to refactor this composable without changing its appearance. Very important. The appearance is still the same. It could happen because maybe we have a deeply nested composable with several rows and columns or whatever, and we want to simplify it. Or maybe we just want to replace a part of that composable because it's very big, and we have also some shared composables, which is also something very common in big projects. Yeah, so you have a shared UI module with composables that we want to reuse in the application because they follow some design guidelines, like I don't know, some paddings, alignments between elements, text and size, text and image sizes, and so on. So after refactoring, you might quickly check that the preview looks as expected, but especially if you modify one of these shared composables in order to achieve the look and feel that you want, you also want to make sure that those changes are not breaking anything in other screens. Therefore, you also run the verify task, which also generates a screenshot file, and then it compares that screenshot file to the one that was previously recorded. And if they are the same, then you have a green build. It means everything is still fine. So could also happen, however, that the generated file is different. And then when both files are compared, then the test fails and says, yeah, sorry, but you've broken something. Usually you would get a diff image highlighting the differences between the original and the new screenshot. And I want to emphasize that the record and verify happen in our machine. Yeah, so while doing CPDD. Everything is executed locally. If you are already familiar with screenshot testing, you're likely used to executing record on your machine, and then you make a pull request, and the verify is executed on the CI. That's fine. You should still do that. But while implementing a new feature with CPDD, you also want to verify locally because it will be much more faster than if you delegate it to the CI. Then you have to wait for runners to be available, and so on. Yeah, and it would slow down a little bit the development. So, talking about speed, that brings me to the next slide. That is JVM-based screenshot testing libraries. Yeah, because everything is executed locally on your machine, and all these libraries, yeah, those are the libraries that we can use for screenshot testing without starting an emulator. And yeah, with them, the thing is that everything is faster because it executes on the JVM. And with those libraries, we can also auto-generate screenshot tests out of previews. I will show you later how. Here, I just want to mention the libraries that they are Paparazzi from Cache App. That was the first one that could execute on the JVM without the need of a device or emulator. Then Composable Preview, that is a very new one from Google, from I think 2 months old, not older. Works pretty fine, I have to say. And then Roborazzi, that is also been there for a while. Yeah, and also allows you to run screenshot tests on the JVM. It is also important to notice that they can be split into those that use layout lib, which is what Android Studio uses to render previews. Yeah, and Roborazzi, yeah, does not use that layout lib. It uses Roboelectric for that, and works also pretty fine. So next, yeah. Exactly. This difference is important, whether it uses layout lib or Roboelectric, because Paparazzi and Compose Preview generate screenshots that are reflection of what you see on the previews. But there are certain things that Preview cannot handle properly, like launch effects, which are used, for example, if you have a lazy column and you want to initially scroll to the bottom of the list, or, for example, to display snack bars. So if you like to have a preview of a snack bar, this would be the result of those tools based on layout lib. You see nothing, but it's because you see nothing, actually, in the preview if you want to display a snack bar. On the other hand, since Roborazzi uses Roboelectric, it's displayed. I'm not saying that it's also always going to be like that. It's just in some cases in which, yeah, you will see some differences with Roborazzi and those tools that are based on layout lib. So you also have to keep in mind that previews are a high fidelity representation of what you would see on the device, but it's not 100% accurate. So enough for screenshot testing. As we've seen before, CPDD is based in 2 concepts. I've already explained the first one. Now it's time for the second one, that is test-driven development and how it relates to Composable Preview Driven Development. So let me take some water. So let's start with the TDD basics. The very first step of TDD is to start writing a failing test. If we put this into the Android context, this means, for instance, creating a method in the view model, like fetching whatever. You likely fake the response that you get from the server, and then you assert some UI state in the view model. So unidirectional, so UDF, unidirectional flow. Yeah, so basically some event happens in the UI, you delegate it to the view model processes this event, generates a UI state, and this UI state is collected in the UI. And this UI state that is generated in the view model is what we want to assert. Based on my experience, this is the main issue that people new to TDD have, what to assert, yeah? How can I assert a UI state if I have no idea of what info this UI state should contain at this point before writing anything? Indeed, we'll see how CPDD helps with that. But for now, this is enough. Let's go to the second step. So write the minimal code to make the test pass. And here I want to emphasize that you should not strive to find an optimal solution. At this point, just get it working with as least code as possible. Because then you have the third step in which you will refactor code. Yeah, you know that the feature works because the test is passing, and now you can start refactoring the code, make it cleaner. And here it's important to make changes little by little. So after every small change, you execute the test, and if you see that something is broken, then you just roll it back, and you are still in a state where everything was working. So that was enough. Yeah, let's talk now about CPDD basics. So if we take a deeper look at this TDD symbol, we can appreciate that it's very similar to the Jetpack compose law. Yeah, it's not accidentally. Indeed, we just need to spin it a little bit, and voila, we have CPDD, yeah? The main difference, actually, between TDD and CPDD is the very first step, as we can also appreciate because of the color. Yeah? In one is red, in the other one is black. While in TDD, it is about writing a failing test, in CPDD, it's writing a preview first. Likely multi-previews, we'll see later, so we can account for different configurations. But there is not such a concept of a failing test. So the second step, what? I was missing some slide, okay. Yeah, the second step is to write UI code in the composable we are previewing till the UI looks as in the design. And once that happens, you execute the record task that we have seen previously. This is like having a green test, because at this point, we know that what the composable displays is what it should. So the code behaves as expected. And finally, as in TDD, we have the refactoring step, where we'll execute the verify task after every small change if possible, and we ensure that everything is looking as it should after making some changes in the UI. Good. Yeah, as you can see, both development processes have a lot in common. The main difference is the first step, as I mentioned. I'm pretty sure the next time that you hear about TDD and Jetpack Compose, you will kind of associate. You have this image probably in your head, what is a good signal. So after explaining the different steps of CPDD, I like to show you the differences between what I call preview last. So you implement the whole feature. So you implement business logic as well as UI. And before creating a pull request, you probably write a preview. That versus writing preview first, that is Composable Preview Driven Development, what I've just explained. So for that, we are going to implement the following screens that we got from our designer step by step. It is a subscription screen with the following states. So first of all, we have content. We have this bot with the bubble as a header, so to speak, and then we have the subscriptions in the middle with the one that is selected and some information that we don't care about. And then the purchase subscription button for the one that we have selected. But subscriptions are not displayed, or to be displayed, you have to fetch them. So you also have a loading state in which we show a placeholder, so some shimmer views instead of a loading indicator. And since you don't have any subscription, the purchase button is disabled. And then, of course, if you are fetching the subscriptions and something fails, then you have the error screen, which shows nothing in the middle. The header is common for all of them. And instead of having a subscription button to buy, there's no subscription, so there is a retry action because you want to fetch again. So let's see how we would implement this with preview last development, or at least what, yeah, in most of the projects I've worked, people do when they're doing this or implementing this feature. So we create a composable for the content screen. And for that, we need a list of subscription items. Those are a visual representation of a subscription, so it contains some information about the subscription, but also whether it's selected or not, for example. But yeah, then we just create the header. It's everything is pseudocode. Yeah, I don't want to bother you with all the details. Then we have the subscriptions. That is a lazy column. This is the only part of the screen that is scrollable. And then, of course, the subscription button that in this case is enabled. Till here, everything is fine. Yeah, no complications. Then it comes the next state that is loading. And since most of the screen remains the same, what people usually do is, okay, let's add an if-else condition to account for the loading state. Yeah. So we pass a parameter, it's loading. And then in the middle, of course, instead of just showing the subscriptions, if it's loading, we show a shimmer row, a couple of them. And then the subscription button, yeah? So if it's loading, then it should be disabled. So we do like this. Here is still everything kind of fine. And then let's go for the error screen. And since we already have some if-else conditions for loading, why not to add more for error state? So yeah, again, you put the variable, you pass it in the composable. Then here you don't have to show anything in the middle. So you just add the condition if it's not error. And then here, instead of a subscription button, we show a retry button. Yeah, so if it's error button, that actually when you click on it, does something different than when buying a subscription. So, and once you are done with all this, you write a preview. Yeah, why not? So there are some issues with this. Here is everything very simplified. But I find that composable code is sometimes very harder to understand. I've seen monstrosities. Not in this case, yeah, it's very simple, but when it's not that simple, I've seen composables that are like huge. I understand absolutely nothing, really. The problem is that there's too much logic in the UI, and it's actually not necessary. I will show you later why. And there is no clear separation of UI state. So if now I'm going to add also an empty state, I also have to go if-else by if-else, checking what is going to be displayed, what is not going to be displayed, and so on. But in my opinion, there are much better ways to do it. And also, preview cannot render due to smart composables. That's not something we have seen here, but it's also something that I've seen happening. Yeah, you've probably heard that UI should be as dumb as possible. That means pass only the info that the UI needs directly. Yeah, however, I've seen people passing view models to composables inside composables, so nested. And yeah, if you have composable with view models as parameters, they cannot render a preview. So I'm gonna check the code and it's like, I don't see what it looks like. Yeah, now I have to start my emulator or my device and run the code on it. But yeah, I can do it, but it's time for me as a reviewer that I'm spending on something that I would not need to do. Yeah, another problem is passing big or deeply nested objects. So in this case, imagine that you pass the subscription object that you get from Google Billing. I don't know if you have worked with Google Billing. The object is a monstrosity. It's huge. It's deeply nested, yeah? But we only want to display maybe price and discount. So when we want to add a preview, we need to mock all the unnecessary data of this subscription object just to make the view compile and display something. And it's like, why? No, you don't need to pass this huge object. You don't need all that information. Well, so now let's see how we would implement the same screenshot following CPDD. So the very first step is to write previews. In order to make the most out of it, there are some rules I strongly recommend to follow, not only for the preview step, but also what we are going to do before recording. That's why it's written pre-record. So the very first one is just one preview per screen UI state, one composable per screen UI state. Yeah, okay. The previous one, what I really mean is that if you have 3 states, like content, loading, and error, you have one composable and one preview for content, one composable and one preview for loading, and the same for error. Then don't avoid code duplication at this point when you are before recording any screenshot. Doesn't matter that you are copy-pasting things. At this point, it's fine. Just get it working. Just make it look as in design. And the third one, the least important, is to define multi-previews. With this, I mean several preview annotations for the same function. So you will get instant feedback not only for the default configuration, but also for non-default configurations, like font scale huge and things like that, while you are implementing the composable. So let's start coding. As I've already mentioned, in CPDD, we start by writing a preview. This, empty. Then we add the app theme, so it will be applied to the composable. And then we create the composable for the content UI state, which requires a list of subscription items. Then we add this composable with some fake subscription items or test double items. And at this point, the preview is already set up. From now on, every change that we make in the content subscription screen down will be reflected on the preview, which is very helpful because we get instant feedback for the code that we are writing. So we add first the header. Oh, it looks nice. Then we add the subscriptions, which is a lazy column, and then the subscription button. So everything looks fine, all good. Then the next one is loading. But this time we'll create a separate composable as if what we have done before doesn't exist. So again, we create the preview, then we create the composable for this UI state, and then we add it to the preview. And again, at this point, we just have to fill this loading subscription screen to make it look as in the design. So again, the header. Then here we have shimmer rows, and then we have the subscription button. In this case, disable. And again, the same with the error. Yeah, the preview, first of all, then the composable, then we put it in the preview, then the header, and in this case, nothing in the middle, so just the error button. So the very good thing of this is that now we have 3 very clearly separated states, one for each design, so to speak. Then we just need to define a screen UI states. So for content with the subscriptions, the loading, and the error. And then we have to glue all states together in a general screen composable. So basically, we are collecting what the view model generates, and then we display the composable accordingly. So here we can see that the code is very well organized. Yeah? So we have this for content, then we have this for loading, and then this for error. So you can see that there is only one when clause in all this code that is in the glue part, so this subscription screen, where we glue all together. Only one statement where we have to check where everything happens. So although everything looks fine in the preview, it is just the standard configuration. Yeah? However, not all the users use the device with these settings. Yeah, it would be interesting to see what happens if the user has set font scale huge. So by doing so, the subscription becomes very small, and that's an issue because it's the only part in our screen that is scrollable. So maybe with one finger, you can try to scroll it. The best solution is probably to make all that scrollable. So the Android bot, the bubble, and also the subscription list. The thing is, for that, you have to make some refactoring, and we are not still in that part. Maybe later you also add a preview for tablets and everything looks super spacious, so you also have to refactor again, and we are still not in that state. That's why I mentioned before the rule start with multi-previews, because in doing so we can check what our composable looks like while we are developing. We are getting instant feedback. From the very beginning, we can check in all the screens that everything is looking fine. And here the point is, the faster you detect a problem, the cheaper it is to fix it. That's why. But anyway, you can always add those extra configurations, previews, at the very end of the pre-recording phase. So the next one is record. I have only one rule here, is don't spend time writing a screenshot test, just write previews and auto-generate the screenshot test out of it. And for that, I've already told you before, we could use any of these JVM-based libraries. However, the way we get a screenshot test out of previews depends on the library that we use. So, with Compose Preview from Google, it is fully automated. You just need to include the corresponding plugin, and then you can execute the record and verify task. The problem is that usually previews are located in the main source. Yeah, and Compose Preview requires them right now. There's an issue to fix that, to be located in the screenshot test source that you might never heard of it. So there is the main source where we have our production code, the test source for tests, Android test for instrumentation test, and there's a new one since AGP 8.5, so Android Gradle plugin 8.5, that is called a screenshot test. And you have basically to take your previews from main, copy them into this screenshot test source, and then you can generate the screenshot test out of those previews that are in a screenshot test source, which means you end up maybe with duplicated previews. But I think Google is gonna also allow to do it from the main, yeah? So you don't have to duplicate things. What about Roborazzi? That is fully automated via Gradle plugin option that is available since one of the last versions. For that, it's important to mention that it's using Composable Preview Scanner under the hood. It's a library that provides a list of all the previews that are located in the main source only. So you don't need to place your previews somewhere else as well. And for Paparazzi, how many of you are using Paparazzi? If you are, okay. It is not fully automated, but anyway, it's not hard to configure. Yeah, you just need one parameterized unit test, and you will feed that parameterized unit test with the previews that you find with this Composable Preview scanner. Yeah, so every time that you add a preview, it will be automatically added to this parameterized unit test, and it will execute. Yeah, talking about this library, I'm actually the author of it. Yeah, it has 30,000 downloads monthly because it's integrated with Roborazzi automatically. I recommend that you take a look at Composable Preview Scanner, especially if you are using Paparazzi, because that is documented how you can integrate it. It's very straightforward. Yeah. And one of the niceties of it is that if you are using Compose multi-platform, which also uses previews, but those preview annotations from Compose multi-platform are different from Android. Yes, different import. Composable Preview Scanner also works with that. You can also find in the README how to configure it. Is also very easy. So the next one, refactoring, the last step actually. And here I have two rules or recommendations. The first one is that the verify task should execute fast. That's why we want to execute the screenshot test on the JVM. And if they execute fast, we are more eager to execute them often, frequently. And that brings me to the second rule, that is verify on every significant change. Yeah, as I explained before, yeah, if After every small refactoring, we execute verify, and the test failed. We just have to roll back the last change, and everything is still working as expected. However, if you do several small refactorings, and you, till the very end, you don't write verify, then it fails at the end, and it's like, okay, I've made this change, this change, this change. Which one is the root of the cause? Why it is my UI broken? So that's the rules. Now let's refactor our composables. They're already quite simple, but if we take a look at the three composables, we see there is something in common. Yeah, so we have the top bar, the header, and the terms that are common to all of them. So avoiding code repetition is cool, so we decide to refactor. So we create a scaffold screen, subscription screen, with all those composables inside. And then what differs, we just pass it as a composable. I think this is called a slot API pattern, but it doesn't matter. What is important is that we are refactoring code because we want to avoid repetition. So, exactly. Now we copy this scaffold. We replace the code that we had in the content composable with that one of this scaffold. And then we have made a small refactoring change. So we execute the test and generates a file, then compares to the original one. If everything is fine, it's green, so our refactoring was fine. And then we do the same for loading and for error. However, let's imagine that we actually modify one of those shared composables that are used in several screens. For instance, in this error screen. And here we can see that the retry button comes with a message. But since it is an error message, it would make sense to display it red. By the way, I'm colorblind, but I'm pretty sure it will be red. So we decide to change it. And if we execute verify now, we would expect this to fail, But it's fine because this change was intentional. However, it turns out that we forgot there is another screen with also a button and a message. And in this case, the message is just info, over 200 mascots to select from. That's not an error message. So if you actually see it red, as a user, I would be like, select another mascot. What is happening with these 200 mascots? Why is red? I would get confused. So it turns out that when we change this composable that is shared, also affected another screen that I completely forgot about. So then you execute the verify, and it will render actually a diff image saying, okay, this is the difference. And I will see that the file, and I will be like, oh, I've broken something. I didn't want to do this. It was an unintentional change. That's the point of a screenshot test. Otherwise, you could always verify with the previews, and you looked at the preview you're working on, everything is fine. But what about other screens? So that's the point of using a screenshot test. So I'm actually at the very end, for those who are leaving. But there is a bonus section with two things I'm going to explain now. 2 points I want to talk about. The first one is the CPDD plus TDD. I like to showcase how good they play together. So if you've ever done TDD before, it's likely that the hardest part for you, as I mentioned before, is to understand what to assert. So here the key is that by doing CPDD first, you already define the US states. So these are the US states that the view model produces, and these US states are also the states that we are going to assert in the unit test. So let's see that with an example. Let's imagine that we get the following requirement. So when fetching at least one subscription, then show only the first one selected. It's dummy, stupid requirement, but for the just to showcase is more than enough. So this is the UI state that the CPDD has given to us. So basically, we have the content state with a subscription item. And in this subscription item, there is also information whether this subscription was selected or not. So before starting to write the business logic to meet that requirement, we can already write the test with the following assertions that you see there down. The first assertion is that only one subscription is selected. So you filter through the subscriptions and the size should be 1. And the second one is that the first subscription is selected. So if you combine those two requirements together, is show only the first one selected. That is what we see in the requirement. And then we could write the business logic in a TDD way inside the view model to make this test pass. So here we can see how CPDD also sets the stage for TDD to make assertions more intuitive. And the second point, let's move to the last part, one of the last slides. Something is still common nowadays is to have in the app a mix of composables with all XML Android views. How many of you are still using Android XML views? Oh, yeah, there's a few hands. Okay. Yeah, I have, The bad news is that I'm sorry for you because you still have to use XML views. Yeah, but the good news is that you can still apply CPDD with them. Yes, you can, because you can create a composable preview out of it. Let's assume that you have the following view holder that you see before. You just have to add this Android view composable. That's from the library. It's not something I came up with. And you can even add another preview for dark mode. And since you have previews, you can apply CPDD. You can refactor the UI logic that is inside this card view holder. And you can always check the preview. You can also generate a screenshot test out of the previews with any of the libraries I mentioned. So it's still applicable to Android XML previews. So just the last slide, but not the least. Let's summarize the advantages of CPDD. So, this is not something that is really related to CPDD. You can also write understandable and maintainable code without CPDD. But I think that doing CPDD with these kind of rules that I mentioned really makes the code more understandable and maintainable. You follow the single responsibility, so one UI state, one composable. Makes the code separation very clear. You just have one clause. If-else clause, in this case was a when, but it's much easier to follow the code than if I have to add a new state and then check the full code of the composable that, as I've mentioned, I've seen monstrosities there. The second one is that you ensure that no visual regression bugs happen in the composables. So we have the previews to get instant feedback when we are developing our current screen. But we also have a screenshot test to automatically verify that we have not broken anything in other screens. And then another nicety is that it makes TDD much easier, or testing behavior becomes much more intuitive. You already define the UI states, and then in your unit test, you just have to assert these states. So your code will be less error prone. So the only, I would say, disadvantage is that to do this kind of things like TDD or CPDD, you need discipline. You have to be disciplined and follow the process. So thanks for your attention. I will publish the slides either on Twitter, X, or LinkedIn. You can also check my GitHub repository. I've done a lot of work on screenshot testing. And that's it. So thank you for attending my talk.